Hi GOR, this is Unit 8, Lesson 1, and today we're going to talk about slope and parallel lines. So in Exercise 1, we have two line segments, A, B, and C, D, and they're graphed for us, and we want to find the slope of both of these lines graphically. Okay, so that's important. I tend to do things algebraically. I'm going to give you the slope formula in a minute, but as long as these are on the graph, it's very easy to find the slope graphically. So you have to remember that slope is the rise of the line to the run of the line. So basically it's the y's that goes on top and the x's that goes on the bottom. So if I want to find the slope of AB, I'm going to find the rise of the y's. So I'm sort of going to box this out. Let me get a red just so it stands out a little bit more. I'm going to see how far up I need to go to get from A to B. And I'm going to count that, and then I'm going to see how far to the right I have to go. All right, so I'm going to do the change in y first. That's the rise. So 1, 2, 3, 4, 5. I'm just counting that. And then I'm going to do the change in x. And I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically, the slope is the change in y over the change in x. So the change in y was 5, the change in x is 10, and I can reduce that. Both of those are divisible by 5, so that gives me 1/2. Okay, notice I was going up 5 and to the right 10. That's why both of those numbers were positive. Any number that starts low, like where the A is, and goes up and to the right, that has a positive slope. CD, we're going to see in a second, has a negative slope. So let me grab a different color for that. So CD, I'm going down, okay? So I'm drawing this in green right here. So let's see how far down I have to go. And then I have to go over. So I went down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I went down 12. And then 1, 2, 3, 4, 5, 6, 7, 8. And 8 to the right. So the change in y was 12. The change in x is 8. And 12 over 8, I can reduce. Both of those are divisible by 4. And I get 3/2. Okay, so that's how I do it graphically. In Algebra 1, you worked a lot with slope. You might have called it average rate of change. And I can do this calculation if I have points. So if I have 2 points, x1, y1, and another point, x2, y2, the slope, again, is the change in y over the change in x. That just means you subtract the y's, that goes on top, and you subtract the x's, that goes on the bottom. So let's try finding slope with the points that I have in Exercise 2. So if it's helpful, you can label these x1, y1, x2, y2. So slope, again, I'll just write it here, change in y over change in x. So just remember the y's go on top and you have to subtract them. So y2 minus y1, 10 minus 4, x2 minus x1. So just be careful with that minus negative. So 10 minus 4 is 6. 8 minus negative 2 is actually a plus positive 2 is 10. And then both of those are divisible by 2, so I get 3/5. All right, and then for B, same thing. I can label these. I think in the beginning, unless you guys are pretty confident with this, I would label these x2, x1, y1, and x2, y2. So my slope is going to be y2, which is negative 9, minus y1, which is 3, and x2, 11, minus x1. So that is a negative 12 over 21. All right, and both of those are divisible by 3. So that's going to give me a negative 4/7. And again, label these. Just make sure that you do it correctly. Y's are going to go on top. 3 minus 11. X's are going to go on the bottom. So that's negative 8 over negative 4. Technically, it doesn't matter which y you start with, but whatever y you start with, you have to start with that same x. Okay? All right, so we also talked about parallel lines back in earlier units. You know that parallel lines are lines that do not intersect, and they have a remarkable property when it comes to their slope. So if you flip this over and you look at the next page, first off, we just want to name the parallel lines. So let me highlight them so we can see that R and N are parallel. And we can see that S and M are parallel to each other. They're two lines that do not intersect. So R is parallel to N and S is parallel to M. So let's find the slope of R and N. Slope of line R. And you can either do it algebraically or graphically. I tend to do things algebraically, but as long as these points are already on the graph, it's actually pretty easy just to do it graphically. And I have points listed, so I just have to see I'm going down and over. So this is going to have a negative slope. Any lines that start high and then go off and down to the right have a negative slope. So 1, 2, 3, 4, 5. So I went down 5 and over 2. And let's find the slope of line N. All right, again, just pick 2 points. So here's one and here's one. So again, I'm going to go down. Let's count 1, 2, 3, 4, 5. So down 5 and over 2. Well, look at that. They have the same slope. Let's see if that happens with the other parallel lines. So let's find the slope of line S and the slope of line M. Now those both have a positive slope because they're going up and to the right. So I'll take these 2 points right here. So I'm going up 2 and then over 3. So it has a slope of 2/3. And line M, again, here's 2 points. I went up 2 and over 3. Oh, look at that. It has the same slope. So what seems to be true about the 2 lines that are parallel? They have the same slope. All right, so here is something important to remember about slope and parallel lines. 2 non-vertical lines will be parallel if and only if their slopes are equal. So all you really need to focus on is that parallel lines have the same slope. Their slopes are equal. Why do we have to put in that stipulation about non-vertical lines? Because a vertical line goes like this, and that actually has no slope. So technically the slopes are not equal to each other because their slopes aren't a number. All right, but don't even worry about that. Just remember that parallel lines have the same slope. That's what you want to remember from this. All right, let's try this problem right here. So I have 4 points, A, B, C, and D, and I want to know if AB is parallel to CD. So in order to know that, I'm going to find the slope of AB, and I'm going to find the slope of CD. Now I'm going to do this algebraically because I have my points right here. So I'll find the slope of AB, and then I'll find the slope of CD. All right, so let's look. X1, Y1, X2, Y2. So 7 minus 1 and 6 minus negative 2. So 7 minus 1 is 6. 6 minus negative 2 is actually 6 plus 2. And both of those are even numbers. They are divisible by 2. Then I'll find the slope of CD. All right, so 6 minus negative 3 and 8 minus negative 4 is 9/12. And again, they're both divisible by 3. Oh, so look at that. They have the same slope. So AB is parallel to CD. Why? They have slopes are equal, slopes are the same, something like that, because it does say give evidence to support your answer. Now I want to know if AC is parallel to BD. All right, so AC, so now I'm looking at these 2. All right, so slope of AC, negative 3 minus 1. I subtract the y's, that goes on top. Negative 4 minus negative 2. So that's negative 4 over negative 2, which is 2. And then I want to find the slope of BD. BD, I'll do that in blue just so that we can see the points that I have. So 6 minus 7 and 8 minus 6 is negative 1/2. All right, so obviously those are not parallel. Not parallel. Why? Slopes are not equal. Or not the same, something like that. Okay, and that's it for slope. So basically, two things you should remember. You should remember slope is the change in y over the change in x. That means you subtract the y's, that goes on top. You subtract the x's, that goes on the bottom. And you should remember that parallel lines have the same slope. And we will practice both of those concepts tomorrow. Parallel lines have the same slope. Perfect.